Hi, my name is Almir Ankic. I am from the North Dakota State University, and I will be presenting on the impact of grid strength on subcycle dynamics in solar PV systems. The increasing penetration of inverter-based resources is changing grid dynamics and challenging grid planning, operation, and protection. Particularly, the increasing integration of IBRs may drive the power grid towards weak grid conditions where potential dynamic stability issues may become significant. One of the major reasons for this generation loss is the tripping of solar generators due to the overvoltage in a less than one cycle time frame experienced by solar photovoltaic inverters, especially when solar PV inverters enter momentary cessation function mode in response to abnormal grid disturbances. In this paper, the impact of grid strength on subcycle dynamics resulting from momentary cessation is investigated in a power system with distributed solar PV integration. In this investigation, distributed solar PVs are modeled with detailed grid-following inverter models considering inverter switching dynamics and momentary cessation function. Grid strength assessment can help grid engineers identify and understand weak grid issues for reliably planning and operating the power grid. The strength of a power grid at a point of interconnection is commonly quantified by the short circuit ratio, which is the ratio of the short circuit capacity at the POI to the rated capacity of injected power from the IBR. The SCR defined here does not account for the interactions among multiple IBRs. Especially when IBRs are electrically close, the interactions have significant impacts on the strength of their POIs. To include the impact for grid strength assessment, the site-dependent short-circuit ratio was proposed by analyzing the relationship between the SCR and voltage stability in a power grid with a single IBR and then extending this relationship to a power grid with multiple IBRs. To investigate the impact of grid strength on subcycle dynamics in power systems with the integration of solar PVs using the RTDS, a power system has been created to include distributed solar PVs. These solar PVs are modeled with detailed grid-following inverter models considering inverter switching dynamics and momentary cessation function using the library components available in RSCAD. A 4-bus system with distributed solar PVs is created in the RTDS using the RSCAD software to investigate the impact of grid strength at different POIs for solar PVs on subcycle dynamics. In this system, the grid is connected to 3 solar PVs via a long transmission line. These 3 solar PVs are integrated into the system via a 35 to 0.315 kV transformer. The grid strength at POIs for solar PVs are evaluated using the SCR and SDSCR respectively. It can be observed from this table that when a POI is electrically far from the grid, its grid strength becomes weaker and thus the SDSCR and the SCR produce lower values. It can be observed that the SDSCR provides more accurate evaluation results of grid strength at buses 1 through 3 in the system. As shown in Table 3, the voltages at buses 1 through 3 are smaller than a typical voltage security requirement of 0.95 pu. Thus, it is expected that the SCR can identify these buses are weak or very weak. That is, according to the commonly used SCR ranges, the SCR values at these 3 buses are expected to be between 2 and 3 or smaller than 2. However, it can be seen from Table 2 that buses 1 and 3 have SCR values much larger than 3, which indicate these 2 buses are strong. In the 4-bus power system, the remote grid fault is applied to trigger the momentary cessation operation mode of each solar PV at the same time. When momentary cessation is applied, solar inverter ceases current injection but remains connected to the grid. It can be observed from these figures that the subcycle overvoltage is induced by momentary cessation, and the subcycle overvoltage not only occurs when momentary cessation starts to cease energy injection, but also happens when momentary cessation restarts to inject energy into the system during the restoration process. In this paper, we investigated the impact of grid strength on subcycle transient characteristics using RTDS-based real-time electromagnetic transient simulations. It is found that undesired subcycle overvoltage is induced by momentary cessation. Moreover, the subcycle overvoltage not only occurs when momentary cessation starts to cease energy injection, but also happens when momentary cessation restarts to inject energy into the system during the restoration process. Furthermore, the subcycle overvoltage becomes more significant when solar PV inverters are integrated into weak points of connection. Our future research will further study the mechanism of the subcycle dynamics and understand the impact of these factors to provide guidelines to avoid grid stability issues due to the subcycle dynamics caused by the momentary cessation of solar PV inverters.